Sometimes when you solve equations, you have to work with variables that end up on both sides of your equal sign. When this happens, our goal is to get the variables on the same side. So today we're going to be looking at how to get the variables on the same side and then solve our equation like we've been doing for the past few days. An important thing to remember is that it does not matter which side you put the variable on. So this is something we may want to star in our notes, because it's not important whether our x is on the left or on the right side. Let's look at example number 1. I have 6x plus 3 equals 8 minus 21. The first thing that I'm going to do is get the variables on the same side. So I'm going to move my x and put it on the left side. If I wanted to move my 6 and put it on the right side, I could have, and I could have subtracted 6 from both sides, but we'll do the 8 this time. So I've subtracted 8 on both sides, and now I'm going to cancel it on the right side, and all I'll have over there is a negative 21. On the left side, 6 minus 8 is negative 2x, and then I'll drop down the plus 3. After that, this is a familiar two-step equation, and so our next step will be to subtract 3 on both sides. And our 3's will disappear, leaving us with a negative 2x is equal to negative 24. And to finish the one step, we're going to divide both sides by negative 2. Negative 24 divided by negative 2 is positive 12. So this one was pretty simple, nothing too difficult. Our next one, we're going to look at what happens when we have some parentheses, and we'll have to distribute to begin with. So anytime you see parentheses, always distribute first and then worry about moving your variables around. So before I worry about putting this c with the 9c, I'm going to first multiply 2. 2 times c is 2c. 2 times negative 6 is negative 12. And then there's nothing to distribute on the right side of the equal sign, so we'll just write 9c plus 2. Now we have a problem that looks like example 1, so let's try to solve it. This time, let's take our 2c and move it to the right side. Once again, it doesn't matter which side you move it on, but just for the sake of variety, let's try something a little bit different with example number 2. So I can see over here, my 2c's will cancel, and the left side has a negative 12 is equal to 7c plus 2. The next thing we'll do is subtract 2 on both sides. Make our 2's cancel. Negative 12 minus 2 is negative 14. I have negative 14 equals 7c. I'm going to divide both sides by 7. And so my c will equal negative 2. So these past two equations have been fairly simple, but sometimes we'll have some special cases, and what will happen in the special cases is sometimes our variables will disappear when we're trying to solve. If that happens, we have two possible answers. One of our answers would be an identity, and we call this an answer when the left side equals the right side. So when we move our variables, if we get something like 5 equals 5, then that is what we call an identity problem. And what that means is that any number you choose to put in place of x, it will make the left side equal the right side. So there are an infinite number of solutions for x for those types of problems. But sometimes when you solve and the variables cancel out, your left side will not equal your right side, and that's what we call a no solution. And that's what happens when we have something like 5 equals 8 after we get rid of our variables. And these can be tricky, so we have to be very careful about how we're solving it. So the first example we're going to look for our special cases is going to be example 3. And I want us to first solve it by distributing. So let's take this 2 and multiply it times the 5. 2 times 5 is 10, and then we'll do 2 times negative 4a. That will give me a negative 8a. Okay. Now, if I'm going to get my a's to be on the same side, I'm going to have to move one of my 8's, and it doesn't matter which one. Let's make this right 8 go to the left 8, and we will move it by adding it on both sides. So I will do a plus 8 on both sides. On the right side, negative 8 plus 8 is going to turn into 0. And on the left side, you guys can see I have the same thing, negative 8 plus 8. What happens when that occurs is that we will cross those out. And on the left side, I have a 10. And on the right side, I have a 10. So let's look back at our different definitions that we have, identity and no solution. Which one does this fit? Since the left side equals the right side, this is an identity problem. And so when we write the answer, we want to write out the word identity. And what this tells me is that I could choose any number I wanted to for A and plug it in, and any number I choose will always make the left side equal the right side. Okay, let's look at our last example problem, example 4. And this will be along the same lines as what we just finished with example 3. I need to get the m's on the same side, and before I do that, I do notice that I have a 7m and a negative m. Let me put those together first. 7m minus m is 6m. So the right side of my equation is going to look like 6m plus 7, and the left side I can just drop down 6m minus 4. Okay, for example 4, let's move our left 6 to the right side. And we're going to move it by subtracting. 6 minus 6 is 0, so that works to cancel out. And I'll do it right here. And once again, we see that 6 minus 6 cancels again. So we're going to cancel one more time. The left side, we have a negative 4. On the right side is a 7. This time the left side does not equal the right side. And when that happens, we write no solution. And what this means for a no solution is that there is no number that I can plug into m that will give me a nice answer. So this one has no answer, and we call that a no solution.